All right, welcome to The Explainer. Today we are diving into a technology that honestly powers some of the biggest websites and apps you use every single day, but it kind of works invisibly, behind the scenes. We're talking about graph databases, and you might be pretty surprised to find out just how much they already shape your digital life.
You know that scene in every crime movie, right? The detective standing in front of this giant corkboard, photos of suspects everywhere, connected by pieces of red string? Well, this quote just nails the whole idea. A graph database is exactly like that investigation board, but it's been supercharged with this crazy powerful engine that can instantly find connections you'd never ever see on your own.
So, what's the official definition? At its very heart, a graph database is a system built specifically to handle data that's super connected. Now, the two keywords here are associative and contextual. It's not just about the photos on the board, see? It's about all those strings connecting them and the stories that those connections tell.
And that, right there, is the crucial difference. In most databases, relationships are kind of an afterthought. It's something the system has to go and figure out on the fly. But in a graph database, those connections, those pieces of red string, they are treated as first-class citizens. They're just as important as the data points themselves. And believe me, that changes everything.
So, to really get what makes graph databases so special, it really helps to compare them to what most of us are familiar with, the traditional relational database. Just think spreadsheets, tables, rows, and columns. It's a completely different way of looking at the world of data.
I mean, just look at the difference in how they're structured. On the left, you've got the relational database, which forces everything into these rigid, predefined tables. If you want to connect a customer to an order, you have to build these special links called keys. But on the right, the graph database is totally fluid. It has nodes, which are the things, and edges, which define the relationships. It creates a much more natural, web-like structure that just makes sense.
And this slide really shows the performance gap. When you ask a relational database to find connections across a bunch of different tables, what's called a join, it has to scan massive amounts of data. It gets slower and slower and slower as your data grows. But a graph database? It was born for this. Each data point or node has a direct pointer to its connections. It just follows the path. It's incredibly fast, even with billions of connections.
This table really brings it all home. Relational databases, with their fixed structure, they're awesome for things like financial transactions, where everything is neat and tidy. But they scale vertically, which means you have to keep buying a bigger, more expensive server. Graph databases scale horizontally. You just add more machines to the team. This makes them absolutely perfect for dynamic, messy, ever-growing data sets like you see in social networks or recommendation engines.
So, how does a graph database actually work under the hood? It might seem really complex, but honestly, it all boils down to just three simple building blocks. Let's break them down.
First up, you have the node. This is simply a thing. It can be a person, a place, a product, an account, really any individual object you want to keep track of. Back on our crime board, these are the photos of the suspects.
Next, and this is the most important part, we have the edge. This is the relationship. It's the verb that connects two nouns. And it's not just a simple line. It has a type, like friends with or purchased, and it has a direction. This is the red string itself, the thing that gives the connection all its meaning. And finally, we have properties. These are all the juicy details that add color and context. A person node can have properties like name and age. A friends with edge can have a property like date started. Properties are basically the descriptive little notes written on the photos and strings of our investigation board.
Okay, so we've got nodes, edges, and properties. It might still sound a little abstract, but I promise you, you're interacting with these systems constantly. So let's look at how these simple building blocks power technology we all recognize.
Okay, think about any social media platform you use. You are a node. Your friends are nodes. The friendship between you, that's an edge. So when the platform suggests someone you might know, it's just running a super simple query. Hey, find the friends of my friends that I'm not already friends with. A graph database can answer that in milliseconds.
Or what about that customers who bought this also bought feature on your favorite online store? That is a graph database at work. It connects you, a node, to the products you've bought, which are other nodes. Then it looks for other people who have bought the same things, finds what else they bought that you haven't, and bam, it makes a recommendation. It's all about matching the patterns in the connections.
And here's a really powerful one, fraud detection. Banks use graph databases to uncover these incredibly sophisticated fraud rings. A single email address being used for multiple different accounts. That's a suspicious pattern. A shared IP address that's connecting people in different countries. That's another huge red flag. A graph database makes these hidden, super complex relationships instantly visible.
So, if you remember only one thing from this entire explainer, please let it be this. Relational databases are great for storing lists of things. But graph databases are designed from the ground up to store not just the things, but the rich, complex web of connections between them.
And that kind of leaves us with a final thought. Our world is becoming more and more interconnected every single day, from our social networks to global supply chains. In this new reality, the data itself is really only half the story. The real value, the real insight often lies in the connections. So the question is, will understanding those relationships soon become more important than the data points themselves? Something to think about.